Hello, welcome back to the Google IT course. Today we're going to discuss about the network layer and the network apps layer. Just a quick overview of what we have discussed in our earlier sessions. We have discussed about networking basics, networking advanced, and the introduction to networking devices. So in that sessions we have learned about the components of network, how to set up network, different types of network, different cables required and their functions, networking devices like router, switch and the cables, etc. So today we have another new session where we're going to learn about the new components of the network layer and its functions, as well as the topic IP addressing and subnetting. So these are going to be the topics for today. Please have a look. What we're going to learn in this session is functions of networking layer, the IP addressing and subnetting. So what does a network layer do? We have discussed in the OSI layer session and the TCP/IP layer session, the network layer is responsible for routing the traffic from one network to another network. Or if you want to access internet, the key component of the networking is the router and it works at the network layer. So the main functions of the network layer are forwarding the data from one network to another network, as well as showing the path to the packet from the local network to the remote network. So in this page we have the functions of the network layer. So we have the router working at the layer 3 and is responsible for the data packets to be transferred from one network to another network. And the key protocols that work in the network layer are the routed protocols and the routing protocols. So the key protocols of network layer are routed protocols and routing protocols. So these are the ones which we will be using in the network layer, and they help us to communicate from one network to another network and allow the data from one PC to another PC. So routed protocols, these are the ones which are very, very important, and they help us to actually send the data from source to destination or from client to the server. And the routing protocols help them to reach their corresponding destinations. So routing protocols and routed protocols are the ones which we will be discussing. The routed protocols are responsible for actually carrying the data from the source computer or source device to the destination device. It could be server or printer. And the examples of the routed protocols or those protocols which actually carry the data between the source and the destination are mentioned here. That is IP, which is the most popular and widely used protocol. But there are other protocols that come under this category called routed protocols. They are IPX and AppleTalk. But practically these protocols are no longer in use today across the world. The only protocol that is used for data communication is the IP protocol, or stands for Internet Protocol. IP stands for Internet Protocol, and it is responsible for carrying the data between the source and the destination. But let us suppose if the source and destination are in different networks, like the best example we could use is internet. In the internet we use a lot of websites. So we access, let us suppose, say google.com or yahoo.com or zoomgroup.com from your computer, from your laptop, or maybe from your smartphone. So when we access this destination, we type the domain name on the browser and we get the web page. But how did it come? Where is this server? How the information is going from your computer or your PC to the server? How does your computer know where the destination is? It's not aware. So these routing protocols help your computer, the request generated by your computer, to reach the destination with the help of these routing protocols. So the router is a key device that allows the local network to communicate with the remote network, and it is on this router we will be enabling these routing protocols, and these routing protocols show the path for the packet to reach the destination. So we will be taking certain examples of how this happens later on in the course. So the network layer functions as routed protocols and routing protocols. Routed protocols carry the data from source computer to the destination computer, either within the same network, same LAN, or maybe different networks. But the routing protocols are there to help your request from the local network to communicate with the remote network. So these are the key functions of the network layer. And we have just seen the routed protocol as IP. IP stands for Internet Protocol. And this comes in two versions. The protocol comes in two versions, as you can see on the screen. The Internet Protocol comes in two different versions, and they are IP version 4, which is the earliest method of sending and receiving data, and it was introduced in the year 1981. The IP version 4 was introduced in the year 1981, the earliest of the protocols, and it has 32 bits, or in the binary format, 32 bits, which is in the binary format, zeros and ones. And the next version of the IP is IP version 6, and this has been introduced later on in the year 2000, and it comes with 128 bits. And the purpose of the IPv6 was to address the depletion of the IPv4 addresses. Though it was introduced in the year 1981, in those days there was no internet, there were hardly any networks. So there was no much usage or utilization of IPv4 addresses. But in the mid 80s and late 80s, when the internet started off, and then where hundreds of thousands of people started accessing internet, everybody required an IP address. So in this way, the IPv4 addresses were getting exhausted quickly. So it may come to a stage where the IP addresses will be fully completed. So then there is no new IPs available for the users to access internet. So that's when the INA, Internet Assigned Numbers Authority, the global body which manages the IP addresses, has created a body where they had to develop the next version of the protocol, and that's when IPv6 was born. And IPv6 was introduced in the year 2000. So this is now the trend that IPv6 is the only protocol available with millions of IP addresses, and it's the way the organizations are moving towards from IP version 4 to IP version 6. So first let us look at the architecture of the IPv4, how many bits it is and how it is represented, and then we will look at IPv6. Okay. So IP version 4 and IP version 6, the small comparison table you can see here. This is a 32-bit addressing system. IP version 4 is 32-bit addressing system. It is 128-bit addressing system. And then IP version 4 is represented in the binary format, 4 octets separated by a dot. We call it as dotted decimal notation. And here you can see an example of an IPv4 address. And in the case of IPv6, which is 128 bits, you can actually see that it is in 8 quadret format. It is in the 8 quadret format, and it is in the hexadecimal notation. And this is an example of an IPv6 address. You can see it's too long we will learn about how to make this address look smaller, but first we will look at IP version 4. So, IP version 4 is a 32-bit addressing system which is very essential and very important. Every network device should have a unique IP address within the network. So, in the last session we have learned about the MAC address, the 48-bit MAC address which is in the hexadecimal notation. We also seen the commands how we can verify the MAC address of a device. If it is a Windows computer, we use the commands get MAC is one of the option which will provide us the MAC address of the device, or we can also use the command ipconfig/all. This will also give us the MAC address of the device. But along with the MAC address, every host in the network which is supposed to send or receive data must have a unique IP address, and this IP address is going to be divided into 4 octets, and in each octet there will be 8 bits. So, there will be 4 octets, each octet will have 8 bits, and in each octet the minimum value will be 0 because all the 8-bit values are 0, the output will be 0, and all the bit values are 1, the value will be 255. So, just look at if these are the 8 bits in one octet, these are the 8 bits in one octet. So, the value will be 0 only. But if the value of these bits is 1, the value is 1 for all the 8 bits, the value is 1. There are 8 bits and all the 8-bit values is 1, then this value will be 255. So, you may be wondering how did we get this value 255? Because this is a binary number system, the first bit value is 2 to the power of 0, the second bit value is 2 to the power of 1, the third bit value is 2 to the power of 2, the next bit value is 2 to the power of 3, and so on, and the last bit value is 2 to the power of 7. So, if you multiply these values 2 to the power of 7 into 1, 2 to the power of 6 into 1, and 2 to the power of 5 into 1, and so on up to 2 to the power of 0 into 1, when we add all these values we get 255. And in the first option, anything multiplied by 0 will be 0. So, in one octet the minimum value is 0, the maximum value is 255. And this IP version 4 is divided or categorized into 5 different classes. They are divided into 5 different classes, IP version 4. And this classification was based on a priority bit. We are going to discuss about what these classes are and how this priority bit will classify. So, these are the 5 classes, and among these 5 classes, the first 3, that is class A, class B and class C, these range of IP addresses are the only ones which we can use in our networks for local area network and wide area network communication, or in other ways to understand, for accessing internet and also for within the organization communication which we call intranet. For internet and intranet communication also we use only the class A, B and C addresses. Then what happens to the class D and class E? What are they used for? So, class D is reserved for multicast communication. So, multicast is a separate type of data communication which we will be discussing shortly what it means. And then the class E are a set of IPs reserved for research and development. They are no longer available for use in the networks. In fact, both class D and class E addresses cannot be assigned to the computers. Only class A, class B and class C addresses can be utilized. So, how do we segment these IP addresses into different classes? So, we have mentioned that in IP version 4 there are 32 bits and these 32 bits are divided into 4 octets. So, we are going to consider the very first octet. So, there are 4 octets, the first octet has 8 bits, and among those 8 bits the ones which have higher value we call them as MSB, most significant bit. So, these most significant bits are reserved for each class, and based on this reservation we will get the range for these classes. So let's look at the priority bit values for these 5 different classes. So this is the range that we just mentioned. The minimum value for every octet is 0. You can see here, when all the bits are 0, the value is 0, and when all the 8-bit values are 1, it is 255. So by substituting this value 0 in all the 4 octets and this value 255 in all the 4 octets, we get the total range of IPv4 addresses. So the starting IP address will be 0.0.0.0, starts here and then goes on up to the last address, which is 255.255.255.255. This is the starting address and this is the ending address, and in between these we have these 5 different classes, and these 5 classes are derived from the priority bit, and the priority bits for each class are mentioned here. For class A, the only one bit is reserved and the value is 0. For class B, the priority bit value is 1 and 0, and for class C it is 1 1 and 0, and for class D it's 111 and for class E it is 4 ones. So by keeping these values reserved, we get the range for each class. So let's go about understanding, by reserving these bits, how do we get the range for each of the classes. So class A range is obtained by having the priority bit value set to 0, and this will be the most significant bit from the 4 octets. You can see this, among these 8 bits, the first bit value is set to 0. This is what we call by priority bit. The rest of the bits we are not concerned, because we are not reserving any bits in these 3 octets. Only in the first octet we reserve the bits. So by keeping the first bit value as 0 and the remaining bits when we change, you can observe that the starting address is always 0 and the ending address for class A is 127. So starting address is 0 and the ending address for class A is 127. So this happens to be the range of IP addresses for class A. So we have seen the total range is from 0.0.0.0 and ends with 255.255.255.255. But for class A, because we have set the priority bit value to 0, by keeping that one bit as 0 throughout, we get the range from 0 to 127. So this is the class A range of IP addresses, and we will be discussing how this will be allocated to the users, organizations and computers. The IP addresses are meant to be assigned to the network devices. So hence we have used this same formula we have to use for the other 4 classes. So when we obtain this range, then we can look at how these are allocated, hierarchy of how the IP addresses are allocated and used. Okay. So let's go to class B now. So in class B, we have 2 priority bits reserved, that is 1 and 0. So out of the 8 bits in the first octet, you can see 2 bits values have been reserved as 1 0, and then the rest of the 6 bits are available for use. So the value starts from 128, as the numbers 0 to 127 has been used up by class A. So class B IP addresses starts from 128 and goes on up to 191. This is the range of IP addresses for class B. So we have got the class B range using the same logic, same formula. We have class C, and this class C, the priority bit values are 3 bits and they are 1, 1 and 0. Hence the priority bit, when you substitute in this, we get the values from 192 and then goes on till 223. This is the range for class C. So you can see the priority bits 1, 1, 0 are reserved, and the range of class C is from 192 up to 223. Just a quick reminder, we have discussed about class A, B and C as the only addresses that we use in our networks today, whereas class D and class C are reserved and cannot be used. So, the priority bit for class D is 1110, and by substituting this value in the first 4 bits of the octet, the value starts from 224 and ends with 239. This is the range for class D, and remember, this is reserved for multicast purposes. It is reserved for multicast purposes. We will be discussing what multicast refers to. And the last class, the first 4 bit values are set to 1, and the value starts from 240 and goes on till 255, which happens to be the very last address. So, this is the total range of IPv4 addresses divided into 5 classes, starting from 0.0.0.0 and ending with 255.255.255. So, how did we get this hierarchy? It is based on the priority bits. So, it is based on the priority bits we were able to classify these IP addresses. And then let us quickly also look at how the IP addresses are managed. How the IP addresses are managed. So, these IPs are managed by an organization called IANA, and it stands for Internet Assigned Numbers Authority. This is the organization, global organization, which allocates the IP addresses to the global users. But under this IANA, or you can also visit the website www.iana.org to get more details about how these IPs are allocated and the different classes, etc. Under this global body, there are 5 sub bodies called RIR, which stands for Regional Internet Registry. Regional Internet Registry. This is the global sub bodies. There are 5 across the globe. According to the regions, they are divided. So, under the IANA, we have 5 regional internet registries, and then they are region based, like say for example Asia Pacific, we have an organization called APNIC. For North America, we have an organization called ARIN. For South America, we have LACNIC. For total African continent, we have AFRINIC, and we have RIPE for Europe, Russia and Middle East. So, the IANA has divided into 5 regions. For each continent is not exactly the continent, but a kind of region. So, for Asia, the Australia, New Zealand, all these come under the Asia Pacific region, and the ISPs in these regions have to approach the registry called APNIC, which is called as RIR, and they allocate the IP addresses. So, the hierarchy is first IANA, so global body to manage both IPv4 and IPv6 addresses. Under this IANA, we have the next category called Regional Internet Registries. There are 5 such registries in this category, depending upon the region they belong to. And under this RIRs, we have ISPs, Internet Service Providers. So, we have the next category called ISP, Internet Service Provider, Internet Service Provider, Internet Service Provider. Under that ISP category, we have the end users. It could be like broadband users like you and me, or it could be organizations. Organizations like companies, government offices, even companies like Google, Cisco, Microsoft, all these are also organizations which take internet bandwidth from the ISPs. Not just bandwidth, basically this allocation of IP addresses. And these IP addresses are so important, but without an IP address you will not be able to send or receive data. And these IP addresses are further categorized into 2 types called public IP addresses and private IP addresses. The purpose of the public IP addresses is to access internet, and when ISP allocates IP address to us, it will be a public IP address, and there is a prerequisite to access internet, one must have a public IP addresses. But not necessarily all organizations will want to connect to internet all the time, or maybe there are certain groups of users who should not be accessing internet at all, or maybe there are some computer labs we have in college and school and university where they are meant to only communicate within the organization, within the library or within the laboratory. So we have a certain set of IP addresses reserved for this internal use, and they are called as private IP addresses. These private IP addresses are not usable or not routable on internet. So to access internet, one must have only public IP addresses, and for accessing within the organization, within the LAN, and we use private IP addresses. And private IP addresses are free. Anybody can use these private IP addresses. You have n number of computers, we can use private IP addresses without any permission or license, whereas public IP addresses are only allocated with the help of ISP. Okay, so let's now look at what we have is the octet format. These are the three classes that we mentioned. They are only usable in our networks. Class D is reserved for multicast, and class E is reserved for research and development. So in this 4 octets for class A, only the first octet is reserved for the network portion, N represents network portion, and the 3 octets are meant for the host portion. We will discuss about what this network and host represents. And similarly, the class B represents 2 octets are network bits and 2 octets are host bits. And in class C, we have 3 network octets and only 1 host octet. So N represents the network portion, H represents the host portion. So N represents the network to which this computer belongs to, and H represents the individual IP address of these local computers. Let's suppose we have a network of 100 computers. These 100 computers will have a unique IP address for each of them, which is represented from the host portion. But to give one identity for this whole network, we represent it by a network address, also called network ID. So we're going to look at how to identify the whole network with one IP address called network ID or network address, and the individual addresses are called as host addresses or valid IP addresses. Within the network, every computer will have a valid unique IP address, and all the network will be represented by one single IP addresses called network ID. So there is a simple formula to understand how to identify this network address and the valid IP address. Also, there is a very special address called broadcast address. If one computer wants to send a message to all the other computers at one single time, then we call that as a broadcast. We call that as a broadcast. So this is a special address reserved in the network. So there are 2 special addresses reserved in the network called network ID and the broadcast ID. These are also called as network address and broadcast address. Apart from these 2, all other IP addresses are valid IP addresses, and we can use it in our networks. So let's look at how to identify this network and broadcast address and valid IP address. So we have the first one as network address. This is also called as network ID. So in an IP address format, which we have just seen, if the bits, all the bits are value set to 0 in the host portion, remember there is n.h.h.h for class A. So the first statement, which is representing the network address, all bits are set to value 0, and it is called as host portion. In the host portion, if the value is set to 0, such type of addresses are called as network addresses. And then the IP address, when all the bits values are set to 1 in the host portion, so when the values are set to 0, it is called as network address. When all the bit values are set to 1 in the host portion, it is called as broadcast address. So network address and broadcast address are the 2 unique IP addresses, and these 2 addresses cannot be assigned to the hosts. We cannot assign these IP addresses to the host. Only a valid IP can be assigned to the host. So remember, network address is always the very first address in the group, very first IP address in the group, either it is class A or class B or class C, the network ID is always the first IP address, whereas the broadcast IP address is the last IP address. So, the valid IP addresses are the ones which are in between the network address, which is the first address, and the broadcast address, which is the last address. So, between the first address and the last address, we have valid IP addresses, and only valid IP address can be assigned to the local computers, to the servers, to the printers, to the smartphones, to the tablets. All these network devices have an IP, and that is called as valid IP address, and that is the one which is very important, that allows us to communicate from the local network to the remote network, or from the source and destination. So, it is important to know that there are two versions of IP address, that is IP version 4 and IP version 6. IP version 4 was the earliest one to be developed in the 1980, and it consists of 32 bits divided into 4 octets, and they are classified into 5 different classes. Among these, class A, class B and class C are important, because only these classes are the ones which we use for local LAN communication and wide area network communication, or in short for internet and intranet purposes. And class D addresses are reserved purely for multicast purposes, and the last one, which is class E, is reserved for research and development. So, let us now look at what we mean by the broadcast. So, before we discuss about broadcast, we have to discuss about the 3 different types of data communication. 3 types of data communication. These are the 3 different types of data communication, that is unicast, two multicast, and 3 broadcast. So, what is the difference between these 3? So, unicast is the one which is generating data communication from one computer to another computer. This is called as unicast. And multicast is the data sent by one computer to a group of computers. Unicast is computer communication from one computer to another computer, or from between the source and the destination, or between the client and the server, or you open a browser on a computer and type zoomgroup.com. So, you are generating a request on the local PC, and the request is going to that server. So, this is a unicast communication, communication from one computer to another computer, or communication from one computer to the server, or communication from one computer to the printer. These are all the examples of unicast communication. In short, we call data communication from one source computer to one destination computer is called unicast. And the multicast is data communication from one computer to a group of computers. There is a difference between all computers and a group of computers. For example, just to understand this multicast, we have radio, right? And the radio, there are different channels. So, you tune to the frequency, you get that program from that particular channel. So, similarly, multicast is you are sending data on one particular multicast IP address. Members in the network who belong to that particular multicast group only will receive. This is called as multicast communication. And then we have the last method of communication, that is broadcast, and this broadcast is message sent to everybody in the network, to everybody, all the computers in the network. That is why it is reserved. So, unicast is a specific data communication between 2 computers. Multicast is communication from one computer to a group of computers in the network, not all of them, very specific group. And the broadcast is from one computer to all the computers in the network. This is called as broadcast. So, these are 3 different types of communication, and for multicast we have a set of IPs under the class D category reserved. So, to our computer we cannot assign these addresses, not available. Class D addresses are not available for computers to use. Also, in the class A, B and C, some IP addresses are reserved. Though we have got the scope and range for each class, if you look at class A, starts from 0.0.0.0 and ends with 127.255.255.255. But among these, the very first address, which is 0.0.0.0, and the very last address, which is 127, are reserved. We cannot use them. So from 0 to 127, 0 and 127 are reserved. So the effective usage of class A addresses is from 1.0.0.0 and ends with 126.255.255.255. 0 has been set aside and reserved, cannot be used, whereas 127 is reserved for loopback purpose. Basically, to check on your computer, does it have the TCP/IP protocol or not. If it has a TCP/IP protocol, then it would respond that there is a reply coming for the loopback IP address. So let's check whether this computer has the protocol or not. So if you check on this computer, I am using the command ping space 127.0.0.1. So this is the IP address that we have set aside, and then we have got a reply from the same IP address 127.0.0.1. We are trying to communicate with that particular IP address, and we are getting response from that particular IP address. So this is the loopback IP address. Not only this particular IP address, any IP address in this series will provide the same response, because this is a loopback IP address, and loopback IP address is only to check whether there is communication within the local operating system. So all these IPs are reserved only for the loopback test. And then let us look at how to assign the IP addresses, reserved IP addresses. The reserved IP addresses are in class A. In class A we have zero dot zero dot zero dot zero, the whole group, and in class A 127.0.0.0. So these two addresses are reserved and cannot be used. And as such, we also discussed about class D and class E. These are the reserved addresses, and we cannot use these addresses. Okay. So along with these IP addresses, we also have something called as subnet mask. So what is this subnet mask? Every IP address will have a subnet mask associated with it. The subnet mask is the one which differentiates between the network bits and the host bits of an IP address. Okay. So later on we will be discussing about this in detail along with the IPv6 addresses in the next session. So in this session we will conclude by discussing about the functions of the network layer, routed protocols, routing protocols, and the IP address and subnet mask with respect to IP version 4. In the next session we will discuss about IPv6 and other functions of the network layer protocol. Thank you for watching this.